Evaluate each expression. All right, so for example A, we have log of 3 to the negative 7 power base 3. So what we're going to do first is we're going to apply this property here in the list that we have on the right. And that property basically says if you have something like this, log of a to the b power, you can bring the power out in front and write it as b times the log of a. So basically we're saying exponents can come out in front as a multiplier in front of the log, right? Can express exponents basically as factors, so they can come out in front and multiply the log itself. All right, so we're able to do that anytime we want. That means we can take this negative 7 here and bring it down to the front. All right, so that'll give us negative 7 log of 3 base 3. Now from here we can apply this rule, which says that log of b base b is always 1. So whenever these two values match up here, you can say the answer is just 1. So that means we have negative 7 times 1. And then, of course, that's just equal to negative 7. Okay, very good. Let's take a look then at example B. For example B, we have ln of e to the square root of 3 power. So let's apply this exponent to a multiplier rule, which says we can write that as a square root of 3 times ln of e. Now, it turns out that ln is just a fancy way to write log base e, right? So if it's log base e of e, then we have this property again, which says what? Whenever you're taking the log of b and your base is b, the answer is just 1, right? So whenever the base and what you're taking the log of match up, you can just say that the overall result is just 1. So bringing down my square root of 3 times ln of e, we can say that ln of e just evaluates to 1. So we end up having square root of 3 times 1, or just the square root of 3. All right, from here, let's look at example C. All right, so to evaluate C, we might want to rewrite it first. In other words, we'll take that ln and say that it's what? Log base e. So when we say ln of 15, we're saying log of 15 base e. Now look, this base matches up with this base, and we have the log in between, right? That's what we're looking at right here. You see this pattern? Base, base, log in between, and what that produces is just the value here that you're originally taking the log of. So we should be able to say that all of this cancels out, leaving you only 15. And that's it. Just like here where the b and the log base b cancel out, and we just left with a. Okay, and then our last example here is example D. So here we have a sum that could be written as a product. So if you want, you could do this. You could say log base 2, right? And then have it as 8 times 4, because over here we have this rule here, the first rule that says that log of a plus log of b is the same as log of a times b. So here our a and b are 8 and 4. So we can say log of 8 times 4 base 2, which is really the same as saying what? Log of 32 base 2. And then remember what this says. This says, what power do we raise 2 to get 32? So we could answer that by saying 5, of course. We could also do it a little bit differently. We could say 32 is 2 to the 5th power. So we can say log of 2 to the 5th power, which is 32, base 2, right? So this 32 is rewritten as 2 to the 5th. And then, of course, we can apply this idea that an exponent can come out in front, correct? So we'd end up being able to say that we'd have 5 log of 2 base 2. And remember what happens when you have this setup, right? This is that idea here. And so we end up saying that that's just 1. So the final answer is 5 times 1, or just 5.